In your final examination, you may be asked to prove the midpoint theorem. You will be given a diagram that looks like this, where the midpoints of two sides will be joined by a straight line. In this case, D is the midpoint of AB, and we can see that AD is equal to DB. E is the midpoint of AC because AE is the same length as EC. The question will ask you to prove the line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. To complete this question, you will need to use construction, statements, and reasons to prove that DE is parallel to BC and that DE is half the length of BC. The first step is to extend line DE to F so that DE is equal to EF. So let's extend line DE to F. We have drawn EF the same length as DE. So let's put 3 small lines on DE and 3 small lines on EF to show that they are equal in length. Then we join FC. So let's do this on our diagram. For step 2, we need to prove that ADE and CFE are congruent triangles. So let's mark triangle ADE in red and triangle CFE in blue. We've just drawn line EF the same length as line DE. So now we can make the statement that DE is equal to EF. We know that these two lines are the same length because we drew it this way. So as our reason, we use construction. The diagram shows us that AE is equal to EC. We know this is true because this information has been given to us. So we use given as our reason. We only have two known equal sides. So now we need to look at angles. We can see in the diagram that AC cuts DF at E. So we can look at vertically opposite angles. Angle E sits inside triangle ADE, and its vertically opposite angle sits in triangle CFE. From our work with angle relationships and straight lines, we know that vertically opposite angles are equal. So now we can say angle AED is equal to angle CEF because they are vertically opposite angles. We now have two equal sides and an equal included angle. So now we have proven that triangle ADE is congruent to triangle CFE, and as our reason, we use side, angle, side. If two triangles are congruent, they are identical. This means that all three corresponding sides are equal and all three corresponding angles are equal as well. So we can mark this information on our diagram. We already know that side AE is equal to side EC, and we constructed EF the same length as side DE. This means the third side AD must be equal to CF. So let's put a small line on CF to show that these sides are equal. Corresponding interior angles are equal as well. We've already proven that angle AED is equal to angle CEF because these are vertically opposite angles. But now we can see that angle A, let's mark it with two curves, is equal to angle C, and that angle D, let's mark it with 3 curves, is equal to angle F. Now we can move on to step 3. Prove that BD is parallel to CF. Let's mark BD and CF in red. For the sake of example, I am going to extend BD to A and make this whole line red. And I'm going to extend CF as well. I've done this for the sake of explanation, but you don't need to extend CF in your examination. We know that if two lines are parallel, then alternative angles are equal. But the converse tells us if alternative angles are equal, then two lines are parallel. And we are going to use this to prove that BD is parallel to CF. DF cuts both BD and CF. So let's make this transversal line purple. Alternative angles sit next to the transversal lines. So we want to focus on angle ADE and angle CFE. So let's tidy up our diagram. I'm going to take out angle A and angle C and angle E as well. We already know that angle ADE is equal to angle CFE because we've already proven that triangle ADE is congruent to triangle CFE. Angle ADE is equal to angle CFE, which shows us that BD is parallel to CF because alternative angles are equal. Now in our diagram, we can put a blue arrow on BD and on CF to show that these sides are parallel. Now I'm going to take out our red lines and put the equal angles back in. In step 4, we need to prove that BDFC is a parallelogram. So let's mark BDFC in our diagram in red. In order to prove that a quadrilateral is a parallelogram, all you need to do is prove that one pair of opposite sides is equal and parallel. We've already proven that BD is equal to CF. So as our reason, we say proven above. We've also proven that BD is parallel to CF. So again, we use proven above as our reason. So we can see that BDFC is a parallelogram. In a parallelogram, both pairs of opposite sides are equal and parallel. This means that DF is equal to BC and DF is parallel to BC. On our diagram, let's put an arrow on DF and an arrow on BC to show that these sides are parallel. Now we can make our diagram black again and move on to step 5. Now we can prove that DE is parallel to BC. We know that DEF is a straight line because we drew it as one. So as our reason, we say construction. We also know that DF is parallel to BC because we've already proven this. If DF is parallel to BC and DEF is a straight line, we can now conclude that DE is parallel to BC. And finally, we can move on to step 6. Prove that DE is equal to half of BC. We know that DF is equal to BC because these are the opposite sides of parallelogram BDFC. But we also know that DE is equal to EF because we drew line EF. So we can use construction as our reason. If DE is equal to EF, then DE must be equal to half the length of DF. We already know that DF is equal to BC, so we can see that DE is equal to half the length of BC.